Rahim. Assalamualaikum and a very good day to everyone. So today we will start, in this video we will start with a new chapter, chapter 4, which is trigonometry. And today we will discuss the first subtopic under chapter 4, 4.1, which is circular measures. Okay, first topic under circular measure, how to convert radian to degree and also degree to radian. Okay, a little bit info. 2 pi radian is equal to 360 degree. Therefore, half of that, pi radian is equal to 180 degree. And from there, we get 1 radian equal to 180 degree over pi. Okay, to convert degree to radian, if you are given a degree, then you can multiply by pi over 180 degree, then you will get the answer in radian. And then to convert radian to degree, okay, if you have radian, then multiply by 180 degree over pi, and what you get is in degree. Let's try question from your homework. To converting radian to degree and vice versa. Convert each of the following angles to degrees correct to 2 decimal places. And let me remind you, it is best if you can change the mode of your calculator to mode radian. Okay, whenever you deal with circular measure, please always check the mode of your calculator. And if you have pi in your calculation, better to use calculator in mode radian. Let me show you. Okay, for example, if you use this kind of calculator, okay, to change the mode, I'm having trouble with the calculator. Wait, okay, shift and then mode setup. Okay, here we have number 4 for radian and number 3 for degree. If you choose number 3, okay, and then now you can check the mode of your calculator now is in degree. Okay, if you want to change to radian, go to shift, mode or setup, and then choose number 4. Okay, and now your calculator is in radian mode. Okay, so for now we use calculator in the radian mode. Okay, let's try the first question. I will not show you everything. Okay, let's just try some of them. Okay, here we have a pi over 4 radian and we want to change into degree. So pi over 4 multiply by 180 degree over pi. So here we can just cancel pi, 180 divided by 4, and the answer we get is 45 degree. Okay, let's try one more. This time we have 4 pi radian. So to change to degree, 4 pi multiply by 180 degree over pi. And again, we can cancel out pi, 180 multiplied by 4. So we get the answer is 720 degree. And then for the second part, now we have 1.4 radian. So 1.4 radian to convert to degree is the same, multiply by 180 degree over pi. Okay, and again, make sure that your calculator mode is in the mode radian. And if you calculate correctly, you should get the answer is 80.21 degree. And then one more, 2.85 radian. So 2.85 multiply by 180 over pi, and make sure your calculator in mode degree, mode radian. Then you calculate 2.85 multiplied by 180 degree over pi. You should get 163.29 degree. Okay, part B. Convert each of the following angles to radians in terms of pi. Okay, previously we convert radian to degree, and now we want to convert degree to pi. Okay, we should multiply the degree by pi over 180. So let's try the first one. 45 degree multiplied by pi over 180. Okay. Just divide 45 divided by 180. You should get 1 over 4. So we can write it down as pi over 4 radian. In the second question, 150 degree. To change into radian, 150 degree multiplied by pi over 180 degree. And from there, 150 divided by 180, we get 5 over 6 pi radian. Okay, this is when we want to leave the answer in pi. Okay, for part C, still we want to convert the degree into radian, but we want to leave the answer in 3 decimal places. So 154.8 degree multiplied by pi over 180 degree, and just use your calculator. You should get 2.702 radian. And again, make sure that your calculator in mode radian. The second question, 95.5 to convert into radian multiplied by pi over 180 degree. Okay, straight away use your calculator. 9.5.5 multiply pi over 180, and make sure calculator in mode radian, and you should get 1.667 radian. Okay, we leave the final answer with 3 decimal places as asked by the question. Okay, next, length of arc of a circle. So arc of a circle is this one, this part. Okay, arc of a circle. The formula to find arc length S is equal to r theta. Okay, arc length S, the length from A to B. Also we can name it as S. R is the radius, and theta is the angle of the arc. Okay, angle in radian. If let's say in question they give you the angle in degree, first you need to convert the angle in degree into angle in radian, because the calculation S equal r theta, theta must be in radian. Okay, so the bigger arc here, we call it as major arc, and the smaller size is the minor arc. Okay, let's try some question. Arc length and perimeter of a sector. Okay, solve each of the following. Okay, let's try question number 1. Find the arc length of a sector with subtended angle of 150 degree and radius of 16 cm. Okay, katakanlah kita cuba draw. Let's try to sketch, but I did not follow exactly the angle here. It's just a sketch. So this angle here is 150 degree and the radius is 16 cm. Okay, remember earlier I mentioned that we have to make sure that the angle given must be in radian. So first let's convert the angle. theta equal 150 degree multiplied by pi over 180 degree. And we will get 5 over 6 pi radian. Okay, and then we can proceed to find the arc length of the sector. This formula S equal to R theta. Okay, radius, given the radius is 16 cm. And then theta, given 150 degree, but we converted the angle into radian, 5 over 6 pi. And then just use your calculator and make sure that the mode is in radian, and you should get 41.89 cm as the answer. Okay, let's try number 2. Given the radius and the arc length of a sector is 5 cm and 10 cm. So again, let's say we have a sector. Okay, and given the radius is 5 cm, so this is the radius, 5 cm, and the arc length is 10 cm, so the arc length is 10 cm. Find the subtended angle theta of the sector in radian. So we can straight away use the formula S equal R theta. We have the radius 5 cm. Theta is the value that we want to find. And then S, the arc length is 10 cm. So theta equal 10 divided by 5. And the answer is 2 radian. Okay, because theta is always in radian. Part B. Okay, let's try question 1. Diagram below shows a circle with center O. Okay, we have center O with an angle theta and P and Q. The length of the minor arc. Okay, the minor arc is the smaller one. So this one is 18 cm. And the angle of the major sector. The major sector is this one. The angle is 280 degree. Find the angle theta in radian. So we want to find the angle of this smaller sector. Okay. For the whole circle, angle is 360 minus the major sector 280 degree, and we are left with 80 degree. So the minor sector is 80 degree in angle. The angle is 60 degree, but we want to convert into radian. So 80 degree multiplied by pi over 180 degree. So we get 4 over 9 pi radian. Okay, so here the theta is 4 over 9 pi, okay, in radian. Okay, then for part B, find the perimeter of the major sector POQ. Okay, perimeter ni ukulele major sector. So P, PO, OQ, QP. Okay, so we must find the radius. Okay, PO and OQ. And then we must find the arc length of PQ. Okay, let's find the radius first by using S equal to R theta. Okay. The arc length of the smaller sector is 18. So 18 equal radius is what we want to find. Okay, radius is the length of PO and QO. Theta is what we calculated earlier, 4 over 9 pi. So again, make sure that the mode of your calculator is in radian. And if you calculate correctly, you should get radius equal 12.8 8916. Okay, I just took 4 decimal places. Okay, radius ni adalah length untuk PO, dan juga QO. Okay. And next, we want to find the arc length of PQ. Okay, arc length of the major sector. We know that the angle is 280 degree, but we must change 280 degree into radian. So 280 multiplied by pi over 180. And we get 14 over 9 pi. Okay, here. 14 over 9 pi. Okay, the angle in radian. And then to find the arc length, okay, arc length of the, sorry, arc length of the major sector, okay, equal to r theta. Okay, this one is the minor sector. Okay, as of the major sector, the radius is the same, so we can take 12.8916 multiplied by the theta is 14 over 9 pi. Okay, and you will get around 63 cm. Okay, as the answer. So here 63 cm. So now we can calculate the perimeter. Okay, the perimeter of the major sector POQ. So PO plus OQ and then plus QP. PO is the radius earlier, 12.8916. OQ is also the radius, 12.8916. And then QP, okay, QP is this one, 63. So let's add all of that, 12.8916. And we get the answer 88.78 cm. Okay, and that is the perimeter of the major sector POQ. One more question. Diagram below shows a sector OAB with center O and sector AMN with center A. So here we have two sector. Okay, a major sector, a bigger sector OAB, and a smaller sector AMN. And then given that OB is 10 cm, AN is 4 cm. Okay, if OB 10 cm, AN 4 cm, then NO is 6 cm. Okay, because the length are supposed to be the same. Because OB and OA is the radius of the larger sector. So if AN is 4 cm, then NO is 6 cm. And then angle MAN is pi over 3 radian. And the length of arc AB is 8 cm. Find the angle of theta in radian. Okay, we want to find this angle. Okay, we know the radius and we know the arc length. Therefore, we can use formula S equal R theta. S is 8 cm. The radius is 10 cm. So we can find the theta. Okay, make sure your calculator is in mode radian. So 8 over 10 is 4 over 5 radian. Or if you want to leave your answer in decimal, 0.8 radian. Okay, either one. Both are correct. That's the answer for part A. For part B, if you want to find the perimeter in cm of the shaded region, so we know This one is 6 cm, 10 cm, 8 cm, 4 cm because radius is the same here. So 4 cm. The only thing we need to find is the arc length of the smaller sector. Okay, we want to find the length of MN. Okay, define MN. Okay, we can use the formula S equal R theta because MN is an arc length. R theta, the radius is 4 and the theta is given pi over 3. So the arc length is around 4.19 cm. Okay, I took 2 decimal places. And then to find the perimeter of shaded region, okay, let's start from OB. So OB plus BA and then AM plus MN and then lastly NO. Okay, back to O. So the length of OB is 10 cm, BA 8 cm, AM 4 cm, MN is the smaller sector arc length we calculated earlier 4.19 and then NO is 6 cm. Okay, let's add all of the value. And we get 32.19 cm as the perimeter of the shaded region. So before this, we learn the formula to calculate the length of arc of a circle. Okay, the arc length here. To calculate S, formula is S equal R theta. R is the radian and R is the radius and theta is the angle in radian. So now we want to learn how to calculate the area of a sector of a circle. So let's say the shaded region here is the sector, and to calculate the area, formula is 1 over 2 r square theta. So A is the area of a sector, R is the radius of the circle, and theta is the angle, but we have to make sure that theta is in radian. So the shaded region is what we call as the minor sector, and here is the major sector. Right, let's try some question from part A. Find the area of a sector with subtended angle of 125 degree and radius of 12 cm. So let's try to sketch. Okay, but this is a very random sketch. I did not follow the angle perfectly. So the angle here is 125 degree and the radius is 12 cm. We want to find the area. So first, remember the angle must be in radian. But for this question, the angle given is in degree. So we must convert 125 degree into radian. So multiply by pi over 180 and we get if I want to leave the answer in fraction, I get 25 over 36 pi. And then to find the area, 1 over 2 r square theta. So 1 over 2, given the radius is 12 cm, so 12 square theta 25 over 36 pi. Okay, and just use your calculator. So again, make sure your calculator is in mode radian and you should get 157.08 cm square. Okay, that is the final answer. Okay, now let's try number 2. Given the radius and the area of a sector is 7 cm and 30.8. Okay, so again, let's say we have a sector and the radius is 7 cm. The area is, okay, the area of the sector is 30.8 cm square. Find the subtended angle theta of the sector in radians. So we want to find theta. We can use formula A equal 1 over 2 r square theta. And we know the area is 30.8, 1 over 2, given radius 7 cm and theta. Okay, calculate carefully. You should get theta equal 1.26 radian. From part B, solve each of the following. The figure below shows the sector POQ of a circle. So POQ, center O, radius 6 cm. The length of the arc PQ is 7 cm. So arc PQ. Okay lah. Okay, 7 cm. Find the area of sector POQ. Okay, the area. Okay, first we need to find the theta. Okay, and we know the radius, we know the arc length. So from there we can use S equal to R theta. The arc length is 7 cm, radius 6 cm, theta. Theta equal 7 over 6 radian. Okay, the theta QOP. To find the sector, area of sector, so A equal 1 over 2 r square theta. Radius is 6 cm and the theta is 7 over 6. So the area is 21 cm square. And then part B. We want to find the area of the shaded region. Okay, shaded region. So we know the area of the sector 21 cm. Next, we have to find the area of the triangle. And then to get the area of shaded region, area of the sector minus with the area of the triangle. Area of sector minus area of triangle to get area of the shaded region. So now our aim is to find area of the triangle. Okay. So we want to find the length of this and this. Okay. Let's name the middle point here as M. Okay, M. So we want to find QM. Here we can use sine. Sine theta is equal to sin theta equal to QM over OQ. Sin theta QM over OQ. And the theta here is 7 over 6. Okay, 7 over 6. But this is only half the triangle. So 7 over 6 divided by 2 is 7 over 12. Okay, half of the theta. The whole theta is 7 over 6. So half of the theta is 7 over 12. QM is the length that we want to find here. QM. And OQ is 6 cm. Okay, again, make sure that your calculator is in mode radian. Calculate sine 7 over 12 and then multiply by 6. You get QM 3.305. Okay, let's try to calculate that first. Sine 7 over 12 multiplied by 6, 3.305. Okay, QM. And then to get QP, QM multiplied by 2. Okay, this whole length multiplied by 2, we get 6.6097. So 6.61 cm. Okay. And then we want to find the length of OM. OM. Okay, OM we can use cos theta. Cos theta equal OM over OM over OQ. And the theta is again is half of 7.6. So cos 7 over 12. OM is what we want to find and OQ is 6 cm. Okay, again, make sure that your calculator is in mode radian. Calculate cos 7 over 12 multiplied by 6. You should get the length of OM 5.008. Okay, now that we know the length of QP and OM, we can find the area of the triangle. And formula is 1 over 2 multiplied by the height OM and the base QP. So the height is 5.008 and the base QP is 6.61. And from there we get the area of the triangle is 16.55 cm square. Okay, now that we know the area of sector and area of triangle, we can subtract these two areas to get the area of the shaded region. So 21 minus 16.55. Final answer is 4.45 cm square. And that is the area of the shaded region. Proceed to question number 2. Diagram below shows a circle with center O and radius 14 cm. So here we have a sector from the whole circle. Radius is 14 cm. Given that P, Q, and R are points such that OP equal PQ. And the angle of OPR is 90 degree. Okay, we want to find the angle QOR in radians. Okay, since we know the value of if OR is 14 cm, length OP equal OQ, then 14 divided by 2, this is 7 cm and this is 7 cm. So we know that OR 14 cm, OP 7 cm. We can use cos theta. Okay, cos theta, this theta equal to the length of OP over the length of OR. So cos theta equal the length of OP is 7 cm because length of OP is half of the length of OR and then OR is 14. To find theta, cos 7 over 14. Okay, calculator. And make sure it's in mode radian. And you should get theta is 1.047 radian. Then for part B, we want to calculate the area in cm square of the shaded region. So, to get the area of shaded region, first we must calculate the area of sector and then minus with the area of the triangle. Okay, sector minus triangle. For now, we do not know both area. Okay, let's find that first, starting from area of the sector. The area of the sector 1 over 2 r square theta. The radius is 14 cm. So 14 square, and the theta is what we calculated earlier, 1.047. And then from there we get that the area of the sector is 102.625 cm square. And now we want to calculate area of the triangle. Okay, area of triangle 1 over 2 multiplied by the height and base. Okay, the height is 7 cm. And then the base. Okay, let's find the base first. PR. For that we can use sine. Okay, sine, the angle is 1.047. Okay, theta here is 1.047. So sine 1.047 is the length of PR over OR. Sine 1.047 equal PR is what we want to find. OR is 14 cm. Okay, calculate sine 1.047 multiplied by 14. You should get 12.123 cm. So 12.123. And we get the area of triangle is 42.43 cm square. And then area of shaded region, area of sector minus area of triangle, 102.625 minus 42.43, we get 60.19 cm square. Okay, that is the area of the shaded region. Next, I would like to try some question from homework 79. I chose first question number 7. Diagram shows 3 arcs PU. So we have PU, lengkungan PU, lengkungan QT dan lengkungan RS. Okay, of 3 circles centered at O with radius OP, OQ and OR. Okay, given OP, PQ is 3 cm. So here 3 cm. Here also 3 cm. OR 12 cm. Okay, if OR 12 cm, minus 3, minus 3. And then here is QR is 6 cm. Okay, because OR 12, so 6 plus 3 plus 3 is 12. And the arc length QT. Okay, QT here is 5 cm. Find the area of the shaded region PQTU and the perimeter of QRST. So we have two questions here. A, we want to find the area. Sorry. area of shaded region PQTU, and then B, we want to find the perimeter of QRST. Okay, let's solve part A. Let's take sector O, Q, T. Because we have the arc length here 5 cm, and then OQ is 6 cm. From there we can find the theta. So S equal R theta. S, the arc length is 5 cm, R 6 cm, and then theta. So theta equal 5 over 6 radian. So we know that the theta is 5 over 6. And then we can find the area. Okay, area of OQT. Area equal 1 over 2 r square theta. 1 over 2, the radius is 6 cm. And the theta is 5 over 6. Okay, in radian, make sure your calculator in mode radian. And we get 15 cm square. Okay, this is from sector OQT. Next, we want to find the area of sector, the smaller sector O. Oh, sorry, very bad drawing. O, P, U. And the radius is 3 cm. Radius 3 cm, theta is the same, 5.6 radian, because they are subtended from the same angle. Okay, the angle here is the same, 5.6 radian, only radius change. So let me sketch that again. Sector O, P, U. The angle the same, but radius 3 cm. So the area of this smaller sector is 15 over 4, or in decimal 3.75 cm square. So to get the area of shaded region, the area of PQ2U is area of area of OQT minus with the area of OPU. And then the answer is 11.25 cm square. Okay, let's solve question B. Perimeter of QRST. QR is 6 cm. So TS is also 6 cm. We know QR, we know TS. We know QT 5 cm. So the only length that we need to find is the arc length of RS. The arc length of RS equal to R theta. The radius. Arc length of RS, so the radius is from O to S. O to S. And theta, again, theta is the same, so 5 over 6. OS, 12 cm, multiplied by 5 over 6. So from there we get 10 cm. To get the perimeter, QR, okay, the length of QR plus RS plus ST, and lastly plus TQ. Okay, QR 6 cm, RS is what we calculated earlier, 10 cm, ST again 6 cm because the length should be the same. And then TQ. TQ is given 5 cm. And the total of that is 27 cm. One more question. I choose question number 9. Figure below shows the sector OBC with the radius 8 cm. So 8 cm. OB pun should be 8 cm. And center at O. Given the length of the arc BC 4.25 cm. Okay. A. Find the angle BOC. So this one. Okay, this angle BOC in radian. Okay, since we know the arc length and the radius, we can use as equal r theta. The arc length is 4.25 cm. The radius is 8 cm multiplied by theta. Okay, make sure your calculator in mode radian and you should get theta equal 17 over 32 radian. For part B, the perimeter ABC. Okay, perimeter ABC. We know that this angle is 17 over 32 radian. So for this triangle, we can use sine theta. Okay, sine theta equal opposite CA over the hypotenuse. Okay, hypotenuse OC. And the angle is 17 over 32. CA is what we want to find and OC, the radius is 8 cm. So calculate sine 17 over 32 multiplied by 8, we get CA equal 4.053 cm. Okay, make sure calculator in mode radian. So now we know CA. Okay, we want the perimeter ABC. So next we want to find OA. For OA, we can use cos theta. Okay, cos OA over OC. Okay, the angle theta in radian is 17 over 32. OA is what we want to find and OC is 8 cm. Okay, calculate cos 17 over 32 using your calculator. Make sure mode in radian, multiply by 8, you should get OA equals 6.897. Okay, now that we know the length of CA and OA, we can calculate the perimeter. Okay, for the perimeter ABC, so AB plus BC and then plus CA. Length of AB is 8 cm. Okay, length of OB minus OA. So 8 cm minus 6.897 plus the length of BC. BC is 4.25 and lastly CA 4.053. And the total we get around 9.4056 cm. Proceed to part C. We want to find the area of the shaded region. So first we calculate the area of the sector and then minus area of the triangle. Okay, let's start from area of the sector. Sector OCD. over 2 r square theta. The radius is 8 cm. So 8 square. And the theta is, okay, again, theta is the same, 17 over 32 radian. Okay, make sure calculated in mode radian. So you should get area of sector as 17 cm square. And next, we want to calculate area of the triangle. Okay, triangle OCA. 1 over 2 multiply by the height CA, 4.053, and the base. The base OA, 8 minus 6.897. So around, okay, OA, oh, okay, ni OA. We calculated OA earlier, 6.897. Okay, 1 over 2 multiplied by CA multiplied by OA. And we get area of triangle as 13.977 cm square. So to find area of shaded region area ABC. Okay, let's name this as 1 and this as 2. So area of sector minus area of triangle. Final answer, we get 3.0232 cm square, and that is the final answer. So I hope you can redo all the questions that we discussed before in this video, and then please solve some of the other question that I did not discuss. Okay, I purposely left out some of the question for you to do by yourself, and you can continue to try more question from homework 79. And that's all for this video. Thank you very much.